Okay, I wanted to just do a review of 4.1 and 4.2 um, for your class today. And so let's just kind of do that together. I would suggest that you follow your notes or look at your notes to complete the things that I put down here just because I'm not going to give a comprehensive view of everything, but let's just kind of review this. So 4.1, you see that? I hope you can see that. 4.1 is discrete random variables, right? Discrete random variables. And probability distributions. All right, so what are some of the definitions that you should know? The first one is random variable. So, like I said, use your notes to memorize these things. I'm going to make a quiz that has this on it. Maybe it'll be on the test. But what is that? So, it's a variable, right? It's numeric and it takes on a value that comes from a probability experiment. And it's random because that value is occurs by chance, right? So it's numeric. It's the outcome of a probability experiment, which depends on chance, right? For example, the number of heads that occurs when you flip a coin 4 times. All right, so know what a random variable is, and then we talked about the difference between discrete and continuous random variables or probability distributions. Discrete means they're countable. There's a fixed number of them, a finite number, I should say. And continuous, there's an infinite number. And just to kind of review, if you see a distribution that looks like this, um, where you have the random variables listed here, this was in class, this was a scale of passive aggressiveness, right? 1 to 5. And each of them happened with a different probability. Can you see that? I wish I could make this brighter. If you see a chart like that, then you know, oh, this is a discrete probability distribution. These are the finite numbers, right? There's 5 of them in this case. Or maybe it would be written like this: 1, 2, 3, 4, 5 with the probabilities under them. Okay, so if you see something like that, you see the problem, you say, okay, this in my head, I'm going to the discrete land of probability, and these have certain calculations, right? Like if you want to find the mean or the standard deviation or the variance, how would I do that, right? How would I do that? So in this case, the way you do that is you go to StatCrunch, Calc, you go to the calculators to, I guess it's Stat Calculator to Custom, right? Stat Calculator Custom to find those things. The other thing that, as far as the definition goes, expected value. All right, so that's written like this. And that is what you would expect if you did the probability experiment like thousands of times. If you did it thousands over and over and over again, like what would you expect the value to be? and it's actually the mean of the random variable. Okay, and so I would hope that you remember what the difference between this expected value and mean is from a random variable as opposed to just a data set of numbers. Remember that? Like the reason I just can't add all these up and divide by 5 to get the mean is because the 3 happens more frequently than the 1. And so I need a weighted mean, right? The expected value for a discrete distribution is the sum of the random variable times the probability of that random variable. So I would do 1 times 0.16 plus 2 times 0.22 all the way down. All right. So it's like an average. It's the central point of this distribution. And this is how it's calculated. And that's for a discrete random variable. Okay. So good. I think that's fine for a review of 4.1. Now, 4.2. We talked about the binomial distribution. All right, so when you see binomial, you know this is a discrete probability distribution. Okay, and there's 4 conditions. And I'm going to abbreviate them because you have them in the notes. The first one is there's only 2 possible outcomes. There's a fixed number of trials. And these trials are independent. And that means that the outcome of one trial doesn't have any effect on the outcome of another. If you flip a coin once, it's a tails. It doesn't influence the next flip. All right, the next one is the probability of success is the same for each trial. Okay, like the 2 outcomes, they're often labeled success and failure. All right, the probability of a success is the same for each trial. And then the last one is the random variable x is equal to the number of successes. All right, so when do you use the binomial? Well, the classic example is when you flip a coin, like we did in class. You flip a coin 4 times, right? And the number of successes determines the random variable, right? So if you flip it 4 times, you have 5 possibilities, 0 through 4. So when you graph that thing, just so you know, typically, these are probabilities, and this x-axis usually is the number of trials. All right, like 0 to 4. It's the random variable. It's 0 to 4. This tells you like how many trials there are. Right, and then this is the probability. Now, how do you find? So for this distribution, there's also a mean, standard deviation, and variance. And with this, you don't use StatCrunch to find that. You calculate it. The mean is n times p, the probability of success. The variance is equal to npq, and the standard deviation is the square root of NPQ. Just to remind you, N is the number of trials. P is the probability of success. Q is equal to 1 minus P, the probability of failure. And is there anything else in here? I guess X just, X is the number of successes. Okay, last part on this. So this is very common. And when do you apply this? Typically, you do it a lot with surveys where there's a yes/no question. A certain percent of the population feels this way or they don't. Okay, and just for a little bit of a theory, I like to explain why it's called the binomial, right? Because that's a binomial, and the expansion on that, for a to the fourth, or a plus b to the fourth, is 1 a to the fourth plus 4 a to the third b to the first plus 6 a squared b squared plus 4 ab cubed plus b to the fourth. Okay, and this is determined by the number of trials, right? Well, it turns out that equation fits perfectly with the probability, and the probability is written like this: n choose x, p to the x, q to the n minus x, right? And so if you look at this, if you remember, this is the number of combinations. And there's a formula for that, right? There's a formula that has factorials in it. And so this is the number of combinations. So all four are heads. There's only one possibility for that, right? And the same with tails. There's only one possibility. This one is for 2 heads and 2 tails, right? So you're taking the probability of 2 heads and 2 tails right here, right? And there's 6 different ways that can happen. Maybe the first 2 are heads and the last 2 are tails, or the first and last are heads and the middle ones are tails. So we did that in class. That explains why they call this the binomial distribution. Okay. To calculate the probabilities, to calculate this, right? So once again, it's going to look like this. This is the random variable, and you're going to have a probability associated with each one of these outcomes, right? What's the probability that I get x equal 2 heads? And to find that probability, you can use this formula, but we're going to use StatCrunch, and I think it goes stat, calc, and then binomial. And that will give you the probabilities for each x. And we did that in class. Now, the last thing I want to do is I'm going to show you how to do this with some programming, and I'll make another video for that. But this is a review. Let's see here. This is a review. Here it is. 4.1 and 4.2. Discrete random variables. It's just there's a fixed number of them, and each of them is associated with a probability. And then one of the distributions is this binomial one that has these properties, often used with surveys, okay? And this is the mathematics behind it, but you just need to recognize, if they're talking about a survey, it's likely the binomial, and it has these characteristics. And to find the probabilities, you can use StatCrunch to do that, okay? I hope that helps you, and I'm going to put another video out on another way to calculate these probabilities.